Hello everyone. For this tutorial video, I'd like to explain vector functions, also called vector valued functions, because they are functions that give you vectors as inputs or outputs, rather than simply regular numbers, aka scalars. A vector function in 2 dimensions would have the x component with t as an input, and the y component with t as an input as well, and would be denoted like this. If the vector function was in 3 dimensions instead, we would have a z component with t as an input to that as well, for the 3rd dimension or the height. So for example, if we're asked to sketch the graph of this vector function, we would see that 1 is a constant for every y value, so the only thing that changes is the x coordinate. In conclusion, we get a horizontal line at y equals 1, because we have not specified a limit or maximum and minimum value on the x. If we have a more complicated function such as this, we will have to stop and think about it, but we can see with some creative thinking that because x equals t, we can substitute this in for the y component, and we get a cubic function, specifically y the cubic function of x. So we see in conclusion that this vector value function gives us a cubic function. However, not every graph of vector functions will give you things similar to normal functions, such as if we are asked to graph this, which we can see once we plot it out, is an ellipse with an x radius of 6 and a y radius of 3. And this should be familiar from parametric equations and calculus 2. Similarly, if we have a graph like this, we see it is nothing more than the parametric equations of x equals the x component and y equals the y component. We can then safely conclude that if we have a 3D vector function, z would be a parametric function of t as well, just like x and y. So for example, if we were asked to sketch this vector function with 3 dimensions rather than simply 2, we would see it still has the circle/ellipse form. The only caveat is that it has a constant height of 3 rather than 0. If we have a t in the z component instead of a constant, like this, it will affect the function differently at different heights. In particular, in this case, we see the x and y components give you the same general circle/ellipse, but now, instead of being a full circle at one height, the height gradually increases the more you go around the circle, so it forms an upward spiral, which is sometimes also called a helix. Lastly, if we have a multivariable vector function instead of vector functions with only one variable input, such as this, we would identify the parametric equations for the x, y, and z components and see if it matches multivariable functions we already know. In this case, luckily it does, where x is simply equal to x, y is simply equal to y, and z is equal to x squared plus y squared. Now that we have figured out how vector functions work in general, we can discuss calculus techniques with them in the next video. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.